Hi, everybody. Welcome to the Microsoft Partner Showcase. I'm Brian Hitney, a solution architect here at Microsoft focused on data and analytics. And today we're joined by Xebia and my colleague, David Giard. I'll start with just throwing this over to David to introduce himself, and then we'll get to the folks at Xebia. David.
Thanks, Brian. I'm also a solution architect. My job is to help great partners like Xebia be successful on our Azure cloud platform. Here's Randy from Xebia. Tell us about himself.
Thank you, David. Randy Pagels is my name. I'm a DevOps architect and a trainer at Xebia. I train mostly on DevOps practices, GitHub end-to-end, and DevOps solutions. Thank you. I'll hand it over to Josh.
Very good. Thank you. I'm Josh Garbrick. I'm a cloud solution architect here at Xebia. Been with the organization for about a year and a half. I've been in the technology space for over 2 decades. Been a Microsoft MVP in Azure, ALM, and developer technologies for the past 10 years. So great to be here and happy to talk all things technology. Blaize, over to you.
Yeah, I'm been at Xebia. I'm Blaize. Been at Xebia for a minute, for about a year and a half, I guess. Not quite as long as Josh or Randy, though. And I am an Azure MVP. I've been an MVP for about 7 years. Mine's been in Azure and IoT. So I've got a lot of background working in IoT and data solutions and that kind of thing on Azure specifically. I just wrote a book about that on O'Reilly. So that's enough about me. But so we're here to talk about Xebia now, I think.
Yeah, actually, let's plug that book, though. What was the name of the book? We'll include a link.
It's architecting IoT solutions on Microsoft Azure.
Very cool.
I had to grab a copy of it. It looks like this. So excellent. Maybe that's architecting IoT solutions on Azure. It's been out for about 3 months now, and on the O'Reilly platform. So get it at Amazon or O'Reilly or. Not the
so do you dive into like real-time analytics at all with that and ingesting data?
Yeah. So like the way this book's organized, it's around it's about a third of it is like just the nuts and bolts of what it takes to actually integrate IoT with Azure, and then the other 2/3 is more about data wrangling and data architecture, and it goes over real-time solutions, and I kind of talk through different kinds of data architectures and how they work and the pros and cons of each, and then the tools and technologies on Azure, how you would implement that and so on. So it's got it's pretty high level because it's more around architecture, but it does talk about the integrations and all of that on Azure and goes through details on how you might go about implementing that. So it'd be Stream Analytics, could be Cosmos DB, could be Azure Data Explorer, it could be any number of things, data lakes. It talks about all kinds of different technologies and stuff. And so,
great. Yeah. I'll have to dive into that in the future because especially with Fabric's focused on real-time intelligence now, I'd be curious to see what your thoughts are there. I'll check out the book too, so I can come in and ask you some questions.
I will say that I wrote this book kind of before the Fabric wave came, so it's already dated.
Yeah, well, that's everything these days.
Yeah, so I wrote it while before Fabric was kind of being announced. So it was
second edition. We'll cover that.
Yeah, hopefully.
There you
second
go.
Edition, sure.
No pressure.
Yeah.
Excellent. Well, great. We'll follow up on that one. Otherwise, I'll tangent and we'll go off on that for a long time. But let's now that we heard a little bit, from an introduction from everybody, and so. Former MVPs, and I think some of you are former Microsofties too, right? So been around the Microsoft technology stack for a long time. I think all of us have, right? So
Yep. And I'm the only former MVP. Blaize and Josh are both current MVPs. I think Randy might be a future MVP.
I may be a future MVP. I'm a former Microsoft, 17 years, app dev space, Azure engineering team for a little while. So I enjoyed my time.
Awesome. Great. Yeah, let's talk a little bit then about Xebia. I know that there's quite a history with it, and there's some name changes and whatnot. So if we can, let's talk a little bit about the company, some of the history, and what it is you do.
So I'll take that one. So Xebia is a worldwide organization. that's been in business for over 10 years. It's a consultancy that focuses in a lot of different technology areas. And Blaize, Randy, and myself were brought on as members of a company that was called Xebia, which was a subsidiary of Xebia. Always been in the Xebia family, had their own independent branding, 23 Microsoft MVPs, 5 regional directors in that group of around 125 to 150 people. So probably one of the highest concentrations, I think, of MVP to FTE that I've seen anywhere. Main mission is really around authority, being able to come in and position ourselves as authorities in the space, regardless of what that space is. And Xebia was really focused on the Microsoft side of things. So that was everything from Azure DevOps to now GitHub, Microsoft Azure, and all things that play in that ecosystem. And over the course of the past couple of years, we've gone through a couple of different rebrandings. There was a notion to kind of become this one Xebia family. And at the end of last year, beginning of this year, we started to go through that and become just Xebia. And really our full title is Xebia Microsoft Services. So we've got several different service lines that cater to different technologies and different needs depending on who you are and what you're looking for. We do have a data practice that deals with everything from Databricks to Snowflake to actual data science, data engineering, and things like that. We obviously complement that with Microsoft-focused solutions that would help further people in that space. So we've got around 6,500 employees. We've trained over, I want to say, it's been 1.3 million folks around the world over the past few years with our Xebia Academy offerings. So that could be any kind of training. I know specifically we focus more on training that's around the Microsoft realm. So whether that's the cloud adoption framework, the well-architected framework, the various GitHub trainings that are out there, everything from regular platform to Copilot through advanced security and administration. So we touch a lot of stuff in that sphere, and it's part of who we are and what we do.
That's very cool. I know a lot of the folks that work there through my work in the community, a lot of well-known people that you've got working with you, including yourselves. And I also know you because I attended a workshop just a few months ago. Tell me about that workshop. I'll hand it to Randy.
Yeah.
Yeah, I was actually going to ask Brian to, we call up that one page, but the idea was to use app dev and some of the technologies like Copilot and advanced security and use that as a kind of wrapper around the core, which was, we call a RAG app using AI and mining data. So the three of us built this workshop to deliver in person that you attended, David, to do more hands-on on how do you build a RAG app and why would you want a RAG app. And we used some of the code. Blaize started with LangChain and put together this basically a presentation and hands-on all-day workshop to present that, and the customers would actually attend it and actually build it. I'll say not build it from scratch, but for sure wire it up to make it work and then use it. So we had that workshop in Chicago where you were, and we also delivered it in Atlanta at our Xebia office there.
You said a couple words there. I want to make sure that we define them.
Yeah.
RAG app. What is that?
That is retrieval augmented generation, meaning that you can combine the power of large language model with other basically data you're training use a data set and combination with a large language model is what that means. So the ability to ask questions and create prompts against that data that's combined together that you wouldn't get out of a large language model. More like current tech, or let's say modern day technology or modern day data.
Good. And you also mentioned LangChain. What is LangChain?
I'll take a stab at this and please jump in. LangChain is the ability to abstract the APIs for interacting with the APIs for a large language model. It just abstracts all the gory details that go with pulling out and interacting with large language models. So LangChain is used out of Python. It's a library, allows us to tap into the APIs, saves a lot of coding. Did I miss anything, Blaize?
Yeah, it's a library that allows you to take various things that are related to building AI powered applications and kind of stitch it together. So it gives you abstractions on different kinds of databases, especially what we call vector databases. It also provides hooks into a lot of different APIs that provide access to large language models like OpenAI on OpenAI's platform, as well as on Azure, and a lot of open source models that do some very similar things if you want to self-host it. And then, of course, it gives you the ability to kind of bring a lot of those tools together under a common set of frameworks that makes, as Randy mentioned, writing code very simple. You just kind of wire up the parameters for connecting to all these different services, and then you just stitch it together, and then it just kind of does all its magic under the hood without having to like do a lot of that coding manually. Which, if you've ever done it manually, you will appreciate LangChain. If you've used LangChain and you've never done it manually, you're like, wow, that was easy, that kind of thing. So,
Got it. So it helps to manage that complexity away.
yeah, it does. It does a great job too.
Every answer leads to another question. Vector database. Can you define that, please?
A vector database is a database scheme. I want to call it a scheme. It's a technology. It's a different way of organizing data. So most people are familiar with, at least by now, relational databases, which uses tables, or document databases, which use like hierarchical data structures, or even more recently things like column store databases and things like that. Well, vector databases is a way of mapping things that are related to one another without having like hard, like defined connections to other entities of the similar type. So it's more about what we call a similarity search. So it's about finding things that are like what you're looking for without actually having to do things like keyword matching or indexing against ID fields or just Boolean type logic to find relevant information. Instead, it's more nebulous, oriented around the relationship of ideas or similarities, if that makes sense. And so when you search a vector database, you're looking for things that are like what you're looking like within your search parameters. So like, say if I wanted to look for pets, well, I'm not going to tell it to look for dogs, cats, and squirrels. I don't guess people keep squirrels for pets, but dogs, cats, and parrots. But if I say search for pets, it's going to know that because I'm looking for pets, that dogs are a likely candidate, cats are a likely candidate, parrots are a likely candidate. And if you want to get even more exotic than that, then you could include things like snakes and iguanas and what have you. So it's looking for related ideas, even without explicitly telling it to search for those kinds of ideas, if that makes sense. And so that similarity search empowers you to search data that's not structured in any way. So think about documents, like just troves of documents, things like Wikipedia, or documents that are in some kind of data store in your basement, on a server somewhere, and no one's touched that data for 15 years, but all of a sudden AI comes along. You say, hey, maybe we can go get some intelligence out of that data in the basement, because now we have a tool that can search it. And so you bring all that data, you go through a process of embedding that data in a database. That's the process of converting just that raw data into what we call vectors, and then searching that data using vector searches, using embedding models, and then analyzing that data using large language models. So it's a combination of a lot of different technologies, but the results are pretty amazing, because now you have natural language queries that you can search against large data sets of unstructured data and get back relevant results. So it seems like magic, but it's really, really, really cool what you can do with it.
So basically what you're saying is I don't have to write regular expressions to search against data anymore, right? It's all vectors.
Right.
So, but the key though, right, is that you need a large volume of data, hence the name large language model, right? To build up enough, say, accuracy in those vectors in the underlying data.
Yeah. That's the cool thing about this technology, is because so much of that's already been done, you don't have to do it. So that's why, like, a lot of these pre-built models that are like on OpenAI with Azure, the embedding models have a lot of that intelligence already baked into the model that you use for creating data. Now, if you want to custom build one, you can certainly do that, or fine tune one, you can do that too. But the fact that you don't have to do that makes accessing this technology within the reach of anybody that knows how to program against an API, really.
Do you find that when people have come into these workshops, is that kind of the light bulb moment for them to see well, we have all this data. How do we basically vectorize? I mean, they're not coming in thinking that off the top of the head, but they're probably, or what I'm asking is, are they wondering, how do we take all of this data that might be in our legacy system, and how do we prepare that for AI? Can you talk a little bit about that experience you've had?
Yeah, so that's actually been one of the biggest asks, because actually building like a fairly straightforward like hello world application is pretty easy to do. Like you can go right into Azure and using Azure's OpenAI Studio, you can build a fairly simple, interactive application using just the portal and have an API that you can call. But where the rubber meets the road is when you get into a lot of these data sets and you're not really sure what you're looking at. And like that's where you get into the process of creating embeddings. And so you get into this like tension between big picture documents, like what's the corpus of this document representing, and the tension between big picture and the granular stuff that is like the actual specific data that you're actually looking for. And so you're trying to search with the big picture idea in mind, but you're looking for the details and the tension between that. And that's where data engineering comes in. So you get into like things like chunking data and the chunking strategies, and what do you use hierarchical indexing on that data, or do you even need that? Or the chunking strategies that will allow you to just create a flatter vector database. There's a lot of different like things that you can tweak in that process that will have huge impacts on the results. So whenever you actually go to search that data. And then the other side of that is also smart prompting. So when you actually get the data in a form that you can search on it, the how you craft prompts and how you search that data will have a big impact on the outputs as well. And so those are the two biggest gotchas that we've seen is just tripping over that process of ingesting data and getting it in a way that you can search on it, and then also like building relevant prompts that will enable an application to not only search that data but analyze it in a way that will return results that what you're looking for. So two big areas that are just not easy tasks. It's more architecture and more just strategy than it is actually the nuts and bolts of the tech. The tech's actually pretty simple to use. It's just figuring out the tuning of that tech that's the hardest part.
And then subsequently watching folks understand how that stuff comes together, and then actually taking the business application of that and applying it to the technology and seeing how they can leverage things. Working with some customers, we've gone through and done more intimate hands-on workshops where we talk about different documentation sources, because they're a company that's grown through acquisition over the past 5 years, and they've got a whole host of things that haven't been integrated together. And folks don't know who does what. They don't know when they're supposed to do it, what system they need to go to request help. Being able to have the technology and then apply it to something that is a known frustration that is now easier to work with is something that I think really lights people up in a good way. And you get to see that aha moment through that when they realize, oh, I can actually tie all this stuff together and get one picture. That's where I think a lot of the power comes from, at least from the business aspect of applying that technology.
Yeah, finding the integration between disparate data sets and disparate organizations, huge challenge.
Yeah. Do you find that then that is the biggest part of the engineering then is doing that data engineering? Is that typically the biggest piece of it then is, okay, so we have this either one legacy system or potentially multiple legacy systems with all this data, but now we have to figure out what technologies we're going to use to prepare the data and basically build transformations and potentially move it into new data sources that then we can build our AI models off of. Is that a big part of it?
Yeah, it's kind of two-sided to that. One is like, if you're going to go the route of building your own models, getting data that's useful for building models so that you can build and test and validate your models. And the other side is if you're going to go with pre-built models, that we find a lot of folks, just it's one customer comes to mind that the biggest problem they were having wasn't using the models at all. It was just getting the data in a shape that they could actually leverage the data meaningfully. And turns out that customer didn't even need large language models at all. They actually went with a solution that was using more purpose-built models for a lot more of the kind of more use case specific NLP type stuff, like summarizations and question answering and that kind of thing. That LLMs can do all that, but this particular one didn't need that. They just mostly needed summarization and question answering and that kind of stuff, and didn't need to invoke these large language models. Therefore, they saved a lot of like time and money and compute by not doing that. Even though they could have done it with LLMs, but it just wasn't. Why use a sledgehammer when you just need a tap hammer? That kind of tension, right? And so it's just finding, there's just so much to sift through in the technology stacks, the data structure, the database options, the data engineering side of that. Then, are we doing it real time? Do we need it real time? Do we do it batch? And then selecting the right models and just making all that work together is a big part of the challenge. So data engineering, yes, is a big part of it. Also just ensuring that you have the right choices for tool and technologies, because truthfully, integrating any of it's not the hard part. It's like all that strategic stuff that's more difficult decisions.
I'll jump in because somebody in the chat window is playing acronym police. LLM is large language model and NLP is natural language processing, for those listening at home.
Yeah. Sorry, I'm doing a lot of like acronyms here.
We're big on acronyms here at Microsoft. One thing I really liked about your workshop is the integration between the pieces. You talked about AI, you talked about data, you talked about the application development around that, and building an entire application out of that. Can you talk about how those pieces fit together?
Yeah, Randy, do you want to show your slide?
Yes.
Real quick. Let me show
Yes.
that.
Let me go ahead and show us share and let me know if you can see it okay, David.
I see it.
So what David's mentioning is kind of these, if we're looking at this slide here, this the top row there, you have, org assessment, which is more about the business context. In the workshop, of course, this is more removed from the business context because it is a lab-oriented, kind of discussion. But there was 3 different areas that we focused on. One of them is data, one of them is AI, and then one is app dev. And all 3 of these are part of this puzzle that you're working with. And as we've been talking a lot about like the data side of things and the AI, but once you kind of understand the process, the app dev then becomes like taking, all right, now we've got this technology, data and AI coming together. How do we like get this into the hands of the users? And that's what the app dev experience is all about. And so within the workshop, what we did is we talked through the process of actually getting the data in the database. We couldn't do that in the workshop just simply because doing data ingestion, especially with embedding models, is not fast. And so you need a lot of time to do that. So we kind of pre-built the data so that we staged the data so that you would have it available for the workshop. But we did have the code available if you wanted to look at that. And that's that whole like taking raw data and then using what we call an embedding model to create the vectors and storing that in the vector database. And then the AI portion of that was, now that we have it in a vector database, we want to search that. So we use an embedding model to search that database, which was, in this case, Cosmos DB using PG Postgres, and then using PG Vector as part of that, and then searching that data using the embedding models that are available in OpenAI. And then once you get the search results back, analyzing that using an LLM, which is a large language model. It's 2 different models, and using the LLMs to analyze the data based on a question that was asked about that data. And then the app dev part is bringing all that together, exposing it through an API, and then creating a client that you could then give to a user and then interact with. So I can actually show you this if you want to see it, if we want to think about that.
Great.
I
Yeah,
would
let's
love
check it
to.
out.
Okay.
I'll go ahead and stop sharing, Blaize, so you can share the screen.
All right. Let me share my screen. Okay. So what I'll do here is I'll walk through the Azure components of this and briefly talk about what we're doing, and then I'll show you the actual app and brief. So behind the scenes, what we have is a Cosmos DB. This is a Cosmos DB instance that, notice it's a Cosmos DB for Postgres SQL, and there's an extension that you turn on inside of this that's called PG Vector, which allows you to do vector database searches against a database that's more traditionally been an RDBMS, a more tabular oriented database, but it has the ability to do this in Cosmos DB. So what we did is we built a script that basically ingested a bunch of questions from Jeopardy, right? So somebody had built a data set of all the questions from Jeopardy over a 10-year span, right? And then they had all those questions, they had their values, the questions and answering. So we built the database for that, so you could search Jeopardy questions. So kind of a trivial data set, but it does adequately demonstrate this. And then to integrate with this,
trivial.
Yeah,
It's trivia questions.
Yeah, no pun intended, right? So to interact with this, what we did is we used Azure's OpenAI AI services on Azure. And so what we did is we had a couple of deployment models that we created. I have a couple of them here, but we have this embedding model right here, which is what we use to create vectors from. So what you do is you take a corpus of text and you pass that to an embedding model, and it spits out what we call a vector. And that vector is just basically a bunch of numbers. And that's what you store in the database. And then to search that, you would basically do the same thing. So if I'm searching this, I use the embedding model, say I ask a question, I create an embedding from my search criteria, and then I use that embedding to search my vector database. And so that embedding model is important for searching and also storing data. And then we have this completion model, and this is my LLM right here. And the completion model is the one that will take the results from my search. After I've done the search using a vector search, it returns those Jeopardy questions back to me. And then it analyzes that data to return some kind of results back to the client. And then if it's a question, then it's going to return results based on the question I asked. If it's like I'm asking it to do some kind of analysis on that, it might be doing some kind of statistical analysis. There's a lot of different things you can do with LLMs. Not going to get into that, but that's what we're doing here with these two models right here. And so those two pieces working together, I have a completion model and an embedding model on OpenAI with Cosmos DB being the Postgres SQL database. Now I bring those together in an application, and that's where we built some code. And this is some very basic code here. And this is where we were talking about using LangChain. So LangChain is just wiring all this up. So we have some stuff that talks about I was using Copilot to write some client apps for this. I was just making sure that would still work. So we used AI-enabled development. I'm using Visual Studio Code here, but you could do this in any app, any environment that uses Copilot. So I was writing Pilot. I was writing front ends for this using Copilot, and then using AI assistants to write AI-enabled applications. So this is wiring up LangChain. This is all my parameters for wiring up this to Cosmos DB and wiring it up to OpenAI on Azure. And then I'm setting up all of these different basically components that are used by LangChain. And this is my prompt template. So we're using some prompting here. I'm saying about a story. This should be about Jeopardy questions, but this is using a prompt template. And then you come down here and then you take that prompt template and you have the context, which is the search results from the database. And you have a question, which is the prompt that the user enters. You bring that together into a prompt template. And then you have all of this kind of come together down here under LangChain. So I have this retriever right here. That's where I do my searches. And then I retrieve some documents and then I wire it up with LangChain saying, here's my prompt, here's my context, here's all of my results. And then LangChain just goes through the process of calling out to that LLM and getting back results. And then this is where I'm just exposing all that through an API. So I'm just using Python to expose an API. Grand total of 100 lines of code to do all that. If you did that manually, it would be about quadruple that amount. So LangChain is just, a lot of that is ceremony too. A very little of this is actual functional code. And so a lot of that is just the ceremony of wiring up Cosmos DB, wiring up OpenAI and all that stuff. And so very simple there. And then we're just exposing that through a static web page, which is just being served up by the application. You know, in a real world application, I would probably have the hosting separately for the static stuff. But in this case, I'm just serving up a static web page, which is just straight up HTML. And that's just calling into this. So to host all this, what I did here is I just created a simple Docker file, and Docker file builds a container, and that then gets pushed out to Azure Container Apps, and I host it on Azure Container Apps. And then I created an instance of it, and then it's all hosted in Azure Container Apps, calling out to a Cosmos DB by way of LangChain, and also calling out to OpenAI by way of LangChain using those APIs. And so you end up with something that looks like this. And so this is my AI research assistant against Jeopardy databases. So can you give me questions and answers about science fiction? And I should get a response here. The demo gods are not with me. And then we got some right here. So we got some questions back about from the database. It just said what kind of questions it's, and then it did a vector search, pulled back these questions from here, and it pulled back 4 in this case, and then gave me an answer right here.
That's the key that I found with a lot of workshops, is to see some kind of implementation at the end to help kind of clarify how something gets implemented, and I want to see it working. So let's talk a quick moment then, because this is great. I love seeing this. I like how it is come together, particularly hosting it then in a container app, because you could just easily push that out, then modify it however you'd like to do that.
Yeah.
What do you see as some of the next challenges, right? Do you see, we're seeing a lot about security around AI, data governance. What do you see in the future regarding that? Is that kind of the next thing that you're seeing, or what are the challenges that you're seeing?
Well, first and foremost, most of the people that are kind of dipping their toe into AI right now are not doing it with PII data. So there's a lot of apprehension about using it in those kinds of contexts where you have any kind of information because that's PII oriented, because they're concerned about the model exposing that data or other kinds of things that relate to how that data might be used internally with a model, and how is it persisted, how is it stored, and so on. And so that is a concern. It's just that because there's not a LLMs as they are non-deterministic, meaning that there's no input. If you prompt something the same way twice, you'll get different results every time, and that creates some concern, because the explainability of that is hard for people. They're like, well, what is it really doing behind the scenes? And these kinds of concerns are definitely out there. And because of that, people are using it mostly for data that isn't PII oriented, but is valuable to their business process. So process documentation is not PII oriented. So searching process documents, searching historical data that doesn't have like PII stuff in it, just old contracts or legal databases, these kinds of things that get into a lot of things that are non-structured but would be useful for this kind of application. That kind of data is very relevant. And so as we move forward, the challenge is going to be like, how can we use it but do it in a way that's secure, and how can we trust it enough to where we're willing to let it analyze PII data, and will it ever be compliant enough to be like used for HIPAA or things like that have a lot of data in that context. I mean, but AI as it sits now is already being used in medical fields, but it's more around like imaging and that kind of thing, and less around and molecule development for medicines and that kind of stuff, but not so much in the records management space and that sort of application.
This is a lot of really good information. I want to just ask you about what's coming up for you folks in specific and for Xebia in general. More workshops, more public offerings? What's going on?
I would say we are looking at additional workshops in the same space that the nice demo that Blaize walked us through. We are kind of taking a step back, reevaluating this, and just we expect to launch a few more workshops. We also hold webinars on different technologies such as Copilot, advanced security, AI type of things. So stay tuned for those. We announce those on either LinkedIn and or Twitter, or both, or X. Sorry, didn't say Twitter. Cut that out, David.
No, that's cool. But send us the links and we'll put those in the show notes. People who want to engage you, is that the best place to go? Just to look on LinkedIn, or is there a better way to?
Our website, Xebia.com.
Xebia.com.
Yeah,
that'd be the best way.
And then you can definitely find the full scope of Xebia there. But of course, Microsoft Services is a part of that, and there's blogs and all the announcements related to workshops and upcoming events and so on. So we're always even if we're always at conferences. So if there's a major conference going on, there's probably somebody from Xebia there. In even smaller conferences, there's probably someone from Xebia there, because we're, just so many people in the Xebia space are out there doing stuff, especially in the Microsoft ecosystem.
I love your commitment to the tech community. It's something that's a passion of mine as well.
I'll dig up some links too. A lot of the MVPs have their own YouTube channel, so they blog on those as well. So
this guy does.
Great.
I'd love to see it.
Yeah, we'll make sure we include all of that then in the notes. So scroll down in the description, you'll see everything in there. So great. Well, thank you, everybody. I know we're at time for the show, but Randy, Josh, Blaize, and of course my co-host today, David, thank you all for taking the time to walk us through this. I look forward to following up with you perhaps in a few months as this matures a little bit, or if you have additional AI related workshops, let's sync up and see where it goes. And maybe we'll talk more also about the real-time and IoT stuff as well, because that's a passion of mine. So we'll have to follow up on that one. But
yeah,
in the meantime, thank you.
Through that for sure.
Great. But anyway, thank you all for joining today, and we'll see you next time on the next Microsoft Partner Showcase. Thanks, everybody. Take care.
Thank you. Thanks for having us.